Okay, we continue by solving these MCQs that are related to week 1. Last time we solved it, we introduced the complex number, and now we start solving the MCQs about the complex numbers. Okay, I hope you review. You had a look to the lecture. No. Okay, so the first exercise says that the complex number minus 1 minus root 3 to power 8 is equal to, so you have the complex number given by minus 1 minus root 3 I all to power 8. Obviously, you can start writing minus 1 minus root 3I multiplied by minus 1 minus root 3I multiplied by until you reach all to power 8, right? But this will take you, remember that for every MCQ you have 3 minutes at the exam, and so this will take you a lot of time. That's why when anytime you have a so high power of a complex number, the best thing to do is to move from the algebraic form, because this, I remind you, is the algebraic form, is to move from the algebraic form to the exponential form. Okay, so we just to remind that we saw that if you have the complex number z equal to a plus ib, the exponential form is z equal to r times exponential of I theta, where r is the square root of a square plus b square, and we saw that theta is equal to r tan of b over a if a is greater than 0, and r tan of b over a plus pi when a is smaller than 0. Is that clear? Nice. In our case, you can see that a is minus 1 and b is minus root 3. So r is going to be square root of 1 square plus root 3 square equal to root of 4 equal to 2. Now the theta, the arguments, is going to be the r tan of minus 1 over root 3, okay, plus pi. Is that clear? Is there any doubt? But this means r tan of minus 1 over root 3 plus pi. What is r tan of minus 1 over root 3? It is important to know some value about the r tangent. For example, r tan of 0 is what? 0. R tan of 1 is pi over 4. Okay, r tan of minus 1 is minus pi over 4. R tan of infinity is pi over 2. R tan of minus infinity is minus pi over 2. And finally, how to keep it in mind? You know, for example, that the sine of pi over 6, the sine of pi over 3 is root 3 over 2, and the cosine of pi over 3 is 1 over 2. This means that we know that the tangent of pi over 3, the tangent of an angle is the sine divided by the cosine. So the tangent of pi over 3, if I do tangent of pi over 3, I will get root 3 over 2 divided by 1 over 2. That will give me root 3. Yes or not? So when you have that we saw that the tangent of pi over 3 is root 3. This means that the arctangent of root 3 is pi over 3. Okay, if the tangent of an angle is root 3, then the arctangent of that value will be an angle, inverse function of the tangent. Is that clear? So I will not prove it again, but also keep in mind that the arctangent of 1 over root 3 is just pi over 6. Okay, so we turning back to our complex number, we knew that theta was, so we saw that theta was this was theta equal to arctan of minus 1 over root 3 plus, am I right? Okay, here the number was this. No, I did a mistake. When I wrote theta here, I wrote a over b, but the formula says b over, yes or not? So theta is the arctan of, what is b? Minus root 3. What is a? Minus 1. Then I have to add plus pi because a is negative. So give me arctan of root 3, yes or not? Plus pi. But what is arctan of root 3? We just proved that arctan of root 3 is actually pi over 3 plus pi. Now this gives you 4 pi over 3. So we got that theta is 4 pi over 3 and r is 2. So our complex number z, that was minus 1 minus root 3 of I, is actually equal to 2 exponential of I times 4 pi over 3. Yes or not? We move from this form to this one. Is that clear? Now remember that we wanted this number to the power 8. Yes or not? So what I just do is that it gives us 2 exponential of I 4 pi over 3 all to power 8. Now I can use this will mean 2 to power 8 multiplied by exponential of, it is going to be 32 pi over 3. Yes or not? When I multiply, so it will be I 32 pi over 3. But when I look at the answer here, I still didn't have it. The last 3 one look like mine, but the angle is not the same. Yes or not? I go back and I say, keep in mind, when you know it from, excuse me, let me just bring down this. Okay, I will go back on it, by the way. Never mind. So this is now this will I remind you that what happens if I take when I take a circle like this and I take this angle theta. This is the angle theta. Okay, if I do theta plus 2 pi, so I stay here at the point theta. If I do a round and I go back, it's the same, right? So theta plus 2 pi is the same. Theta plus 4 pi is the same because it just means 2 rounds. Because 1 round is 2 pi. Yes or not? So let's take the angle 32 pi over 3 and see if there is another way to write it. When you want to what is the from 32 is not, I cannot divide 32 by 3, right? But at least I can divide 30 by 3. So I can write it like 30 over 3 plus 2 over 3 all multiplied by pi. Yes or not? So this will give me 30 over 3 will give me 10 plus 2 over 3 all multiplied by pi. And thus give us 10 pi plus 2 over 3 pi. But this 10 pi, how many rounds it means? How many rounds it means? 5 rounds, because each round, so these are just 5 rounds. Okay, so these are just 5 rounds, so it just brings to the same, so the angle here is just 2 over 3 pi. Is that clear? and thus the z can be written as 2 to power 8 exponential of I to pi over 3. Is that clear? Okay, let's go and see which one was the answer. Don't know what is going on here, but we shall be able to go back on the MCQ. Otherwise so there are some problems. Let us fix them. In a few minutes we turn back on the okay. I will be obliged to close it, but no problem. Let's connect. Let's go here on this and half this. Okay, nice. So I got back the MCQs. Nice. Okay, so we got that. You can see from here that the answer is D, right? You got the step. Nice. Okay, so what is the main idea, the main outcome of this question is that if you have a very high power of a complex number, use the trigonometric the exponential representation to compute it. Okay, nice. Now the equation 5z to power to this equation here. Okay, before solving MCQ number 2, okay, maybe we first solve MCQ number 3, and in the next lecture I will explain you how to compute the n root of a complex number before solving MCQ number 2. Okay, so let's go straight to MCQ number 3, then I will go back on MCQ number 2. Okay, so the MCQ number 3 says the complex number I to power 27 plus I to power 33 is, so you have you have the following complex number. You are given the complex number z equal to I to power 27 plus I to power 33. So let's write it. Z equal to I to power 27 plus I to power 33. Okay, now, and you are asked to compute how much is it. Now I remind you that I square is actually equal to -1, so I cube is I square times I is just minus I, right? Now I to power 4 will just mean I square multiplied by I square. That will mean -1 times -1 equal to 1. Okay, so anytime you do I to power 4, you have 1. This is so anytime we write it in red, because anytime you have this kind of exercise, you should keep in mind this property. This property is very important. Why is it important? Because now I to power 27, I know that 27, when I do 27 divided by 4, I get 6 times, right? 6 times 4, which is 24, and the remainder is 3. Is that clear? When I do 33 divided by 4, how much time? How I get 8 times. 8 times 4 divided 8 is 32, and the remainder is 1. Okay, so then just wait a moment please, I need to fix my microphone. Okay, is that clear? So then we can write that from this, you directly see that we have that 27 is nothing else than 6 like 4 times 6 plus 3, right? And 33 is 4 times 8 plus 1. So you can rewrite the number back like I to the power 4 times 6 plus 3 plus I to the power 4 times 8 plus 1, right? But using the property of the powers, you know that this is going to be I to power 4 all to power 8, but this all to power 6. This will give you I to power 4 times 6, right? That you multiply by I to power 3. Is that clear? Plus here is going to be I to power 4 all to power 8 that you multiply by I. But I remind you that I to power 4 is actually 1. But 1 to power 6 is 1. So you remain just directly with I cube plus I. Okay? But I cube, this is I cube. I cube is minus I. So this gives you minus I plus I. That gives you 0. And so the answer for this MCQ is B. So we have the answer 3B. Is that clear? Okay, nice. This concludes this first video section recording, and in the next section we talk about the n root of a complex number. Then we solve number 2. Thank you.